Today's goal is to use the quadratic formula to solve quadratic equations. Okay, so yesterday we were solving. Again, our goal is to solve or find solutions. What values will make the equation true? Again, we're using quadratic equations. Those are things with equal signs that have the form ax squared plus bx plus c. And today, what's different is that we're not factoring. We have a new strategy on our hands. Let's take a look at what the quadratic formula is. This is the formula, and this is telling us x represents the solution to an equation in the form ax squared plus bx plus c is 0. So that is, x will only be equal to these values if you're solving an equation that looks like this. This is called the standard form of a quadratic equation. Standard form meaning it's not factored. It looks like the sum of three terms, ax squared plus bx plus c equals 0. Let's put this into action. My first question is, why do we even need the quadratic formula? I liked factoring. We're good at factoring. Why can't we just solve by factoring? Well, normally we'd try looking for two numbers that multiply to -24 and add up to -3. Like, well, 1 and 24 aren't going to work. They won't add up to 3. Neither will 2 and 12. But what about 3 and 8? Ooh, those aren't going to add up to 3. 4 and 6? Yeah, we're out of factors, so this expression cannot be factored. Factoring is a great strategy to use if the expression can be factored, but we need a strategy in the event that an expression can't be factored. The great thing about the quadratic formula is that it works every time. It's a little bit long, but it works every time. Okay, so let's write out our formula. I like to sing the song so I can remember what it is. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so, wanted to make sure it's clear where my square root ends. So I need to identify a, b, and c. A is the coefficient of x squared. It's not written in this case, so it would be +1. B would be the coefficient of x. So in this case, it's -3, and c would be that constant, the number by itself, meaning it doesn't have a variable. It would be, in this case, -24. So I've written out the formula, which you need to do every time. It'll help you remember. Now I just substitute. -b means use the opposite sign of what b is. So my b is -3. That means I'm going to use the opposite sign, or make 3 positive here. Plus or minus the square root of b squared minus 4 times a, that's 1, times c, -24, all over, all meaning this 3 is also over 2a. Okay, so I have 3, x equals 3 plus or minus. I'm going to do some of this work inside of the square root first. I'll do the squaring, then I will multiply these three numbers. I want to keep this, I want to keep the negative sign out of there so I can subtract next. Okay, so -3 squared gives me 9 minus 4 times 1 times -24 will give me -96 all over 2. So I have x equals 3 plus or minus 9 minus a -96. That turns into 9 plus 96, which gives me 105 all over 2. And then finally, I'm going to break this apart. So I have my two solutions. X equals 3/2, 3 over 2, plus square root of 105 over 2, and 3/2 minus square root of 105 over 2. Here are my two solutions. To those of you that have been working to simplify your square roots, you'll notice 105 is 5 times 21. 21 is 7 times 3. So these are all prime numbers. That is to say, there aren't any perfect squares that divide 105. So this is actually fully simplified. Okay, let's take a look at example 2. Much like factoring, the quadratic formula can only be applied once you have all the terms on one side of the equation. That is, you need ax squared plus bx plus c to be equal to 0. So we have to start by moving this 6v. So we have 9v squared minus 6v minus 11 is 0. I'm putting them in order because that will help me identify my a, b, and c term. Now we haven't talked about factoring if this leading coefficient, the coefficient of x squared, is not 1. So I don't have any strategies as of yet to factor. Let's go ahead and use our quadratic formula. This time v equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's identify a, b, and c and substitute. Negative b, meaning again change the sign. Again, we're going to do the operations. Order of operations tells us PEMDAS, parentheses, exponents, multiplication and division. So let's take care of that first. Minus 4 times 9 times negative 11. That's going to give me negative 396. Again, I've got minus a negative here that'll turn into plus. So I have 6 plus or minus the square root of 432 all over 18. I'm going to split it apart. So I have v equals 6 over 18 plus root 432 over 18 and 6 over 18 minus square root of 432 over 18. You've probably noticed 6 over 18 is a third. So you have 1/3 plus or minus the square root of 432 over 18. This is a fully accurate answer. You're welcome to stop here. Those of you challenging yourselves to simplify square roots will notice 432 is 16 times 27. So you would have v equals 1/3 plus or minus square root of 16. Square root of 27 would be 9 times 3 all over 18. So you'd get v equals 1/3 plus or minus 4. Square root of 9 would be 3. These are all next to each other or being multiplied. You still got that square root of 3 over 18. So v is 1/3 plus or minus 12 over 18 root 3, or 1/3 plus or minus, I'm going to reduce the fraction outside of the root, so that would be 2/3 square root of 3. Okay, fine. One more example. Let's take a look at 4m squared minus 9m is 0. If we use the quadratic formula, we're ready to go because it's already equal to 0. So m equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we can substitute. This time I've got my a term would be here. Here's my b term. The c is the constant, the number with no variable attached, and there isn't one, so c would be 0. That's like saying this equation is the same thing as 4m squared minus 9m plus 0 equals 0. Okay, so we substitute. M is 9 plus or minus the square root of negative 9 squared. Okay. Do the operations inside the root first. Now we can combine whatever's inside the root. And we see we get square root of 81. Well, we know that square root of 81 is 9. So here are my two solutions. 9 plus 9 over 8 and 9 minus 9 over 8. That would give me 18 over 8 and 0, or 9 halves and 0. But I'm hoping, this was quite a bit of work, I'm hoping some of you thought to yourselves, anytime I'm solving a quadratic equation, I might want to start by factoring first. Ooh, they both have an m. You take the m out, you get 4m minus 9 is 0. If I have two things that multiply to 0, one of those things must be 0 themselves. So you get m equals 0 is one solution, and m equals 9/4 is your other solution. Oop, must have made a mistake here, right? We can reduce 18/2, divide by 2, divide by 2. So this should have been 9/4, my mistake. You should get the same answer either way. I suggest you start by trying to factor first. If you can, it's much faster than using the quadratic formula. If you cannot factor, the quadratic formula will always work.